Okay, so we are going to continue factoring this week. We are doing chapter 8-8 in your textbook. It's called A Difference of Two Squares. It starts on page 516, so please read your textbook. And you can follow around. You can take notes in your textbook. And then do these, and that makes it easier, or just watch the video and Google. Alright, so the first thing you want to do, and I didn't do a typed out notes because I got a lot of messages saying that you didn't have a printer and you were going to do it by hand, so I thought, hey, this week let's just do them all by hand. So the first thing you want to do, put your name, put the heading, factor a difference of two squares. You can note what chapter it is and what page, and always, pause the video. So the first thing we need to do is make a list of perfect squares. And we talked about these in class. These are numbers that are used a lot in algebra. They're like celebrities. It's every number squared. So 1 squared, 2 squared, 3 squared. These are perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and this goes on forever. We can stop at 12, but you need to have this list out when you are factoring a difference of two squares, because these numbers show up in every problem. So in order to factor this, you must have perfect squares in the problem. And what's interesting is that you also must have a minus sign, because this is called a difference of two squares. And the word difference means subtraction. So here's our first problem, x squared minus 25. We're hoping to rewrite this in factored form, which means we need two parentheses. We're going to put the variable in first, and then we're going to think, just like we did before with factoring, you're going to think of two numbers that multiply to negative 25 and add to 0. That's what's interesting about these problems, is there isn't anything in the middle. Normally, when we were factoring our quadratics, there was a middle term here that we were trying to add to. And since there isn't an x term in the middle, we're actually trying to add to 0. So what are two numbers that will multiply to negative 25? We have 5 times negative 5, and what two numbers add to 0? Well, 5 plus a negative 5 is 0, so those are our numbers. So we have x plus 5, x minus 5. Factored form, done. So it's interesting, when there isn't a middle term, you wanted to use a plus and a minus sign so that these two numbers cancel out. And when it's a perfect square, you're really just going to look. The square root of 25 is 5, so I knew that my factors were going to be 5, because when you're factoring with perfect squares, you use their square roots. Let's do another one. M squared minus 49, and if you want to pause the video and write these problems down, you can. So m squared minus 49, we're going to go to two sets of parentheses. We're going to look at our list of perfect squares. Does 49 show up? Yes, it does right here. 49 is 7 squared. So I know this factors to be m plus 7, m minus 7. And that's because 7 times negative 7 is 49. And 7 minus 7 would give us a 0 in the middle. If you want to, you can check by foiling. Do first, outer, inner, last, and check. So I'm going to do m times m is m squared. M times negative 7 is negative 7m. Distribute the positive 7. 7 times negative 7 is negative 49. So if I do double distribution here, I end up with m squared. The middle two cancel out because it's a negative 7 and a positive 7, and I have a minus 49 at the end, exactly what I started with. So remember, when it comes to factoring, you can always multiply to check. Number 3, y squared minus 81. When I factor this, I want two sets of parentheses. I'm going to put the variable in first. The square root of 81 is 9. So I'm going to do y plus 9, y minus 9. And that's done. Now, 4 and 5 are different. They have numbers in the front, whereas in our first 3, the leading coefficient was the invisible 1. So these numbers also have to be perfect squares. So is 4 a perfect square? Yes, it is. It's 2 squared. And is 36 a perfect square? Yes, it is. So these numbers have to be perfect squares, and so do the second numbers. All right, so in factoring number 4, two sets of parentheses. Instead of just x here, I'm going to square root the 4 and put 2x and 2x. And that's 4 square rooted gave me this 2. And the x next. 100 square rooted is 10. So I'm going to do a plus 10 and a minus 10. And that is factored. And if we were to FOIL it, we would get 4x squared minus 20x plus 20x, which would cancel, minus 100, leaving the original problem. All right, 36m squared minus 121. We want two sets of parentheses. The square root of 36 is 6, and I'm going to put the variable m with it. I know I'm going to have to do a plus and a minus because the middle term is canceled. And the square root of 121, I'm not sure, I'm not as familiar with. I look, it's 11, so I just have an 11 here and 11 here. And that one is done. 4 more. Go ahead, pause the video, write the problems. All of these are going to factor the same way to two sets of parentheses. The square root of 16 is 4, so 4x goes first. The square root of 1 is 1. We do a plus and a minus, and that's done. The square root of 4 is 2, so I have 2x and 2x. We do a plus and a minus. The square root of 25 is 5. The square root of 49 is 7. There's going to be an m here. We do a plus and a minus, and this is interesting. The second number has a variable as well. So not only do we have two perfect squares, we also have multiple variables here. So when I square root 144, the square root of 144 is 12. I'm going to put an x with it. So the m is first and the x is second in both sets of parentheses. All right, last one, the square root of 25 is 5. We'll do a plus and a minus. The square root of 36 is 6, but since there's a y, we also need a y with it. Okay, you guys will be practicing this on ALEKS and Khan Academy, and I included a Quizlet for you. Please go to the Quizlet and practice it on there. It'll help as well. Thanks.